You're standing in a house with no lights, no signal, no hum of a fridge in the background, and somewhere in a drawer you've got a handful of parts most people would call junk. Here's the strange part. Those parts, wired the right way, can turn on a light. Not solar, not wind, not a single wire running back to a power company. Just heat, motion, and a little chemistry doing what it's always quietly done. Today, we're walking through the real, physically honest ways ordinary people have kept the lights on when every conventional option was off the table. This is Hidden Fix Lab, and this one gets weird in the best way. Let's start with the problem. Solar panels need sun. Wind turbines need open space most people don't have. Generators need fuel, which runs out exactly when you need it most. And grid power assumes there's a grid left standing. After a storm, in a cabin past the last gas station, or in a blackout dragging into its third day, all of those assumptions collapse at once. What's left is a decision. Sit in the dark or start looking at your surroundings differently. Here's the part almost nobody talks about. Long before off-grid was a hashtag, isolated communities generated small amounts of electricity from things that had nothing to do with sun or wind at all. Heat differences, moving water, basic chemical reactions, even the vibration of a floorboard. None of it powered a whole house, but it kept radios talking and lanterns lit in places the grid never reached. That's genuinely useful knowledge that got buried under a century of just plug it in. Rewind to isolated mountain towns before power lines ever made the climb. People with a wood stove and nothing else discovered something curious. Press two different metals together, heat one side while the other stays cool, and electrons start moving on their own. It's called the thermoelectric effect, and it's not folklore, it's basic physics that NASA still uses to keep deep space probes running decades after launch, using nothing but the heat from decaying plutonium. At home, the same principle works on a tiny scale. Clip a modern thermoelectric generator to a hot wood stove. The temperature difference alone pushes out enough current to trickle charge a phone or run a low-power LED. It won't run your kitchen, but it turns heat you were already producing into electricity you weren't expecting. The logic is simple once you see it. Heat wants to flow from hot to cold, and if you make electrons ride along for that trip, you get current. No moving parts, no extra fuel, just a device about the size of a deck of cards, tapping a flow that would otherwise vanish into the air. If you don't have a fire, but you've got moving water, that opens another door. Forget hydroelectric dams. Think smaller, almost absurdly smaller. Portable micro-hydro turbines, some no bigger than a water bottle, work the way a mill wheel did centuries ago. Water pushes a turbine, the turbine spins a magnet past copper coils, and that motion generates a steady current. People in the Appalachian Hills and off-grid Alaska have run a garden hose or a diverted creek through a turbine no larger than a thermos, getting a quiet trickle of power that never stops as long as the water keeps moving. Now say you've got neither fire nor flowing water. This is where it gets strange because your own kitchen is a low-grade chemical battery waiting to be noticed. Stick copper and zinc into a potato, a lemon, or salted water, and a small voltage appears between them. The same principle inside every battery you've ever owned. One lemon won't do much, but wire a few dozen in series, and you can light a small LED or run a basic clock. Aid workers in remote posts have scaled up exactly this trick, salt water and scrap metal, into functioning backup power when nothing else was available. There's also the oldest trick in the book, your own effort. Hand-crank generators predate the light bulb's popularity, running on the same principle as everything else here. Motion, moving a magnet past copper coils. A few minutes of cranking can charge a small battery pack enough for an hour of light or a short call. It's the one power source that never runs out as long as you're willing to put in the effort. So why isn't any of this common knowledge? Mostly because it doesn't scale, and scale is what the modern energy business is built on. Utilities profit from centralized, always-on power delivered through infrastructure that took decades and billions to build. Tiny personal generation methods were never going to threaten that model, so they quietly slid into the survivalist niche, even though the physics behind them is taught in every high school science class. You can see these ideas at work in bigger, unglamorous places too. Remote clinics in northern Canada have used waste heat to keep vaccine refrigerators running through fuel shortages. Fishing boats off the Maine coast have used residual engine heat to keep navigation lights lit, engine off. Train stations in Tokyo have tested floor tiles that turn footsteps into small bursts of power for sensors and signage. None of it replaces the grid. All of it proves energy is often just sitting there, unused, waiting for the right small device to catch it. If you want to try this, start simple. A hand crank or basic power bank is the cheapest way to understand how small amounts of stored energy get used efficiently. If you regularly burn wood, a clip-on thermoelectric generator is a reasonable next step, usually rated to charge phones directly. If you've got reliable moving water, research portable micro-hydro turbines rated for your flow and elevation drop, since even a few feet of drop over 100 yards can be enough. Treat chemical setups as an educational backup only. good for a single LED in a genuine pinch, not daily power. And pair any of these with a small rechargeable battery bank as a buffer, since none of them deliver power in a smooth, constant stream. A word of honesty, because this channel doesn't do hype. None of these methods will run a fridge, a laptop, and your Wi-Fi router at once. They're not a replacement for solar, wind, or the grid. They're a bridge, something to keep essentials going when the bridge you normally rely on is out. Thermoelectric generators need a real, sustained heat source to be worth the cost. Microhydro needs consistent flow. Chemical batteries degrade fast and produce very little. Treat any claim of free unlimited power with the same skepticism you'd give any too good to be true pitch, because the honest version of this story is smaller, slower, and far more useful than the exaggerated one. What all of this really points to isn't a secret the power companies are hiding from you. It's a mindset the grid quietly trained us out of. The habit of noticing energy already moving around us in heat, water, motion, and chemistry, instead of assuming power only exists behind a switch. The people who've kept lights on in blackouts and cabins for the last century weren't hiding forbidden technology. They were just paying attention to physics everyone else had stopped noticing. That kind of attention doesn't run out, doesn't need a subscription, and doesn't depend on anyone's permission. It's just there, waiting for you to look. That's it for this one from Hidden Fix Lab. Keep noticing what everyone else walks past.